Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to have a discussion on how to solve logarithmic equations and the rules that you must know. There's 8 rules that you must know in order to answer any question to do with logarithmic equation. If you're new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials like these ones, you'll be notified. Now, these are the rules that we are going to use in order to solve different questions involving logarithmic equations. Now, going to look at the first question here. Looking at the first question on our disposal, we are told that find the value of a such that log 8 over a log 8 base a equals to 3 over 4, and then we are going to follow step by step on how to approach that. And because the concept that they are trying to use here is the rule that if you are having log b base a is equals to x is the same as a raised to power x is equals to b, meaning that the base raised to the number that is on this side is going to be equal to this b that we have here. So this is the rule we are using. So we are going to say, using rule number 8, we are going to say a raised to power 3 over 4 is equals to what? Is equals to 8, right? And from the laws of indices, if we are having this one, we can be able to write it as the fourth root of a because of this 4 here. Then if this is raised to power 3 is equals to 8, which means that we are going to find cube root both sides, so that this and this will cancel out. We end up having the fourth root of a is equal to cube root of 8 is basically 2. Now, in order to get rid of the fourth root, we are going to raise to power 4. We raise to power 4, and of course this and this will cancel out, and we shall have our a is equivalent to 16 as our final answer in this point. So you must know that log of b base a equals to x can be expressed in index notation as a raised to power x is equals to this number here. So meaning the base raised to the number that you have here is equal to the b that we have at this point. So understanding conversion of logarithmic notation to index notation and index notation to logarithmic notation is very important as far as further pure math is concerned. The next question is that we need to show that 3x log x base 2 minus 4 log 8 base 16 plus 6x log 8 base 4 minus x log x base 2 is equals to log 8x raised to power 3x minus 1 base 2. So we are going to verify that whatever we have on the left hand side is equal to the right hand side. How are we going to go about this particular question? Now follow me with me here. We're going to say, now in order to solve this question, what we're going to do, because this question has base 2 at the end, and we are trying to show that this part we have on the left hand side is equals to what is on the right hand side. So meaning that we are going to express every log that is here to the base of 2. So for us to express that, you need to remember that if you are having log a base b, if you want to introduce a different new alien, if you want to introduce a new alien base that was not there, you are going to say log a over log b, then you introduce that base that you want to introduce. So for instance, if you are having log 27 base 9 and you want to express this to the base of 2, you are going to say this is going to be equal to log 27 over log 9, then you introduce the base of 2 that you want to introduce. Basically, that is how you use this equation rule number 5. Now, in order to work out this, we're going to say we are going to express 2 base 2. That is the basis. Now, the first term here is going to be 3x log x base 2 is in the right base minus 4. This is log 8 base 16. So we are going to express that to base 2. So we are going to say log 8 over log 16, 8 over 16. Then we introduce the new base that we are interested with. For this one, we are going to say plus 6x log. The base is different, so we're going to say log 8 over log 4. Then we introduce the base that we want. But this one is in the correct base, so we are going to write it the way it is. Log x to the base of 2. Now, something that I need to remind you is that we can be able to log 16 base 2 can be written as log 2 power 4, because 16 can be written 2 power 4, and we write our base there. From rule number 3, if you're having log a raised to power m, you can take m behind the log. So meaning that we can be able to say this is 4 log 2 base 2. Which will mean also we can be able to apply rule number 4, log m base m is 1. If you have a log of a number and the base is the same number, you are going to have 1 there. So meaning that this is going to be 4 at the end of the day. This meaning that this number we have here, we can replace that with 4. And let's see, we are having log 4 base 2. This can be written as log 2 base power 2 base 2. And this is 2 log 2 base 2. And that is going to be 2. And this part here can be replaced with 2. So our new expression now will become 3 log x base 2 minus 4 log 8 base 2 over 4 plus 6x log 8 base 2 over 2 minus log x base 2. So finally, we shall have this reducing to 3x log x base 2 minus this, and this will be log 8 base 2 plus this will go here 3x log 8 base 2 minus log x base 2 log x base 2. We need to go further, and in that way we can be able to say, let me put the like terms together, because we can say 3x log x base 2 minus log x base 2 minus log this, and that x base and 2, then plus this one, it will be plus 3x log 8 base 2 minus log 8 base 2, this one here. So which means that we are going to factor out, we are going to group this together here, and we are going to have 3x minus 1 log x base 2 plus 3x minus 1 log 8 base 2. So if we have this, we can see that using rule number 3 in the reverse, if you are having m log a, you can take m up to be the power of a. All right, and then that is exactly what we are going to do here. We are going to take the powers up like that, and let me just try this. This can be written as log x power 3x minus 1 base 2 plus log 8 power 3x minus 1 base 2. And remember, when logs are added, we can be able to multiply them and express as a single log, which means log a plus log b, we can be able to say that's log a times b. At the same time, if you are having the same power, m power a times m power a times n power a is the same as m times n power a. Believe we are together up to that point. So I would like to make use of this space here because we are almost done with this question, and this part I believe you got value on how to work out this question. Let's now try to go further and simplify whatever we have as a single log. So this is going to be log of x raised to power 3x minus 1 multiplied to 8 raised to power 3x minus 1 to the base of 2. So if I have this, I can say now this is going together that way. And using this rule here, that if m power a times n power a, they are having the same powers, we can be able to say this can be expressed as log x times 8, that would be 8x raised to power 3x minus 1, right? And that is basically what we have here. What you need to remember is that we have shown that this part that we have here from the previous question, that that is equivalent to log, the whole of this is equivalent to the log of 8x raised to power 3x minus 1 to the base 2. The whole of this is equals to this. Then now we can say, since we are told to solve this, they wanted us to simplify and know that this, so the whole of this can simplify to this. So they want us to solve this equation. So which means that we are going to say whatever we have said this is equivalent to can be equated to 0. So this is the equation that we need to solve in order to find the value of x. Now, the two ways we're going to approach this, we're going to say this is going to be log of 2. Now, in order to solve this, you can be able to remember the rule we use. In order to solve this, we are going to express in logarithmic notation. But before going into that, remember this rule that we are having here. If you're having log a power m, can be the power m can be written behind the log. So in that way, we can say this is going to be what? We can say this can be solved in the form of 3x minus 1 log 8x base 2 is equals to 0. And in order to proceed, we can say if we divide by 3x minus 1, divide by 3x minus 1, what's going to happen? Let's see the worst that can happen. This will cancel out, and finally we shall have log 8x base 2 is equals to 0. Now, in index notation, this can be expressed how? Log b base a equals to x can be written as a power x, the base raised to the number that you have at this position. So meaning the base here is 2. We can be able to write this as, we can be able to say this in index notation, this can be written as 8x 2 raised to power 0 is 8x. We can be able to write it that way. This number raised to 0 equals to 8x. So meaning that 8x is equals to 1 because any number raised to 0 is basically 1. And we can say divide by 8, x is going to be equal to 1 over 8. That is one of the way we can be able to approach this question at this point. Another way we could approach this question is dealing with this expressing index notation while keeping this intact the way it is. And let me show you what I'm trying to say. We can be able to express this in index notation without taking the power down. So we are going to have 8x raised to power 3x minus 1 is equals to 2 raised to power 0. 2 raised to power 0. If you write that, it's going to be 8x 3x minus 1 is equals to 1. Now, how can you be able to get a 1 when you have a base 8x? The only you can do that is when you have 8 base x raised to power 3x minus 1 is equals to 8x raised to 0. That's when you can have a 1 here. So in order to work out what x is, we can say since the bases are equal, we can equate the powers, and that would be 3x minus 1 is equals to 0, and this goes on the other side. We shall have 3x is equals to 1 here, then divide by 3, then divide by 3, and this point. And if you can open your eyes widely, you will see that 3 and 3 will commit suicide and have x is equals to 1 over 3 as the second answer. So you can have x equals to 1 over 8 or x equals to 1 over 3 for you to be able to have this as the solution of this equation that we were having at this particular point. If you are new to Prof Learn YouTube channel, consider subscribing so that anytime I'm going to upload a tutorial like this one, you'll be notified. Let's move to the next question. Now, looking at these two questions, we can see profoundly, we can see that vividly what is coming out is having different bases. Looking at this question and this question, we're having different bases. So meaning that you have really to master rule number 5. Now, in order to work out this, we are going to express everything to the base of 2 so that we can be able to find this equation. And to that, I'm going to say this is going to be log x power 3 base 2 plus. How am I going to express this to base 2? I'm going to say this is going to be log x squared over log 4, log x squared over 4, then I introduce the base I want. And then this will be minus 3 log of this to the base of this is to the base of x. So I can say this is going to be 2 over log x, then I introduce the base 2 that I want. Then I'll say now this is equals to what? Is equals to 0. Is equals to 0. All right, so this guy is a standalone there. Meaning, if we are going to simplify this, and I've mentioned and opined from the previous section that if you are having log 4 base 2 is the same as log 2 squared base 2. So this power can go behind and have log 2 base 2, and the answer is 2 here. So this part that we have here can be replaced with 2, and meaning that our expression is going to reduce to log x cubed base 2 plus log x squared base 2 over 2 minus, and this one log 2 base 2, when you have log m base m, the answer is 1. When the base, the number, and the log base is the same, you say 1. So this is going to reduce to minus 3 over log x base 2, and everything is equals to 0. We are almost home and dry. So we can say this can be written as this can be written as, we can take the powers down behind the log. So we are going to say 3 log x base 2 plus 2 log x base 2 over 2, and this will cancel out, minus 3 over log x base 2 is equals to 0. If I want to make things cleaner here, I can see that I'll have 3 log x base 2 plus log x, because this is basically having 3 log x base 2, 1 log x base 2. I can be able to add these two logs, and I'll say this is the same as 4 log x base 2, because here is like we are having 1. 3 plus 1, because they are having the same number and the same base, I can be able to say 3 plus 1 becomes 4 log x base 2 minus 3 over log x base 2 is equals to 0. Now, before I start working out this question, let me make use of this space for this part. And then I'll have to say that if we are having log 4 log x base 2 minus 3 over log x base 2 is equals to 0, there is no rule that I can be able to use to multiply this. So I can say let log x base 2 be equal to another letter m. So meaning my equation here can become 4m minus 3 over m is equals to 0. And at that point, I can be able to multiply m all through, and I'll end up having 4m squared minus 3 is equals to 0. Which will mean that our 4m squared will be 3 divided by 4 divided by 4. M squared will be 3 over 4. Then we can now find square root both sides, and our m will be plus or minus root 3 over 2. So once we have this, we can be able to find the value of x, because we are going to say the first value of x is going to be log x base 2 is equals to the positive one here, and that will be root 3 over 2. Now, using index notation, we can be able to say this expression that we have here can be written in index notation, and that will be x will be equals to 2 raised to power root 3 over 2. This raised by the number that we have here. And if you work it out, you are going to get the first answer for that is going to be 1.82 as the first answer to this expression. 1.82, because we are supposed to give our answer correct to 3 significant figures in this question. Correct to 3 significant figures. The second part will be now equating. The next solution for x is going to be x log x to base 2 is equal to negative root 3 over 2 at that point. So also we express it in index notation. So meaning that we are going to say this is going to be what? This is going to be 2 raised to power what? 2, our x that we have here is going to be 2 raised to power negative root 3 over 2. And if you work it out, you are going to get your answer being equivalent to 0.549 as your final answer in this case. So for this problem that we are having here, you are supposed to get 2 solutions for x. In this third question that we are having, also is the same scenario. We are using rule number 5 to convert the base which are different to the same base in order to find the solution. So we can say this can be written as, which base can we write? We can express the last base, base 2, everything this base 4, base 16, base 2. So let's express this to base 2, and this is going to be log x over log 4, introduce the new base that you want, plus log x over log 16, introduce the new base that you want, plus log x base 2 is equal to 10.5. Now, once we have this, then we can be able to simplify. This can be written as log x base 2 over, this is the same as 2. 4 can be written as power 2, and power can be taken 2 power 2, and the power can be taken behind the log. So we can say this can be expressed as 2 log 2 base 2 plus log x base 2 over, this 16 can be written as 2 power 4, and the power can be taken behind the log. So that can be 4 log 2 base 2 plus log x base 2 is equal to 10.5. This will be 1, this will be 1, and then we end up having our expression as 1 over 2 log x base 2 plus 1 over 4 log x base 2 plus 1, that's log x base 2 is equals to 10.5. If you can simplify this, you see we shall have 1 over 2 plus 1 over 4 plus 1 log x base 2 is equal to 10.5. If we add everything that we have at this point, we can see we are going to have everything reducing to what? Everything reducing to, if you add all this all through, we are going to have everything 7 over 4 x base 2 log x base 2 is equals to 10.5 times 4 times 4, then we divide by 7 both sides. Our expression is going to become log x base 2 is equals to 10.5 times 4 over 7, which is log x base 2 is equals to 6. And now in index notation, if you're having log b base a, that can be written as x a, the base a raised to pi this number, and this is going to be our x is equals to 2 raised to power 6, which is going to be equal to 64 as the final answer in this case. In that regard, I want you to appreciate the fact that we are given this, we can be able to express it to base 2 and base 3. You see here we have base 2, we have base 3 here, we have base 4 here, we have base 9. There's no way we can be able to deal with these questions when they have different bases like that. We can decide to express them to the base of 2, and to those ones we cannot be able to express to the base of 2, we can express them to the base of 3. Now, in that case, let's look at this. The first equation becomes 2 log x over log 4. I told you, if you want to express this to the base of 2, just take log of x over the log of 4. Log of x to the log of 4, and then introduce the new base that you are interested. Introduce the new base that you are interested with. Then plus, this is going to be expressed as, if you can look at this, it can be written as log 3 base 3 plus 2 log y base 3, because if two numbers are multiplied, you can add the individual logs. I just decided that I'm going to split this part that we are having here. It can be written as 2 power 2. Then we can say this equation becomes log x base 2 over log 2 power 2 base 2 is equals to 1, because log 3 base 3 is 1 from this rule that we have here. And then plus this going to be 2 log y base 3, meaning that we can take 2 behind the log, so we shall have 2 log x base 2 over 2 log 2 base 2, and 2 base 2 using the same rule will be 1, and equals to 1 plus 2 log y base 2. This and this will cancel out. We end up having this becoming 1. We are having log x base 2 minus 2 log y base 3 is equals to 1. Now, this is the equation that is representing this in terms of base 2 and base 3. So you can be able to say our equation number 1 that we're going to solve is log x base 2 minus 2 log y base 3 is equals to 1. This is equation number 1. Then we need also to do the same. We have to try as much as possible also to express this to the base of 2 and the base of 3. So the first term is log x power 3 base 2. That is, I think it's good. It's doing well. This one is doing well. This term is doing well. Then this one is not doing well. So we are going to say that is going to be 8. We have to deal with it saccharmoniously, and this is going to be log of y over log of 9, log of y over log of 9. We want to introduce base 3. So we shall say base 3, base 3. And this is everything, everything here is equals to 13. Now, at this point of time, take this power behind the log, so we shall have 3 log x base 2 plus 8. This one we can be able to write the way it is, log y base 3 over, this can be written as 2 log 3 base 3, because if you take this power up, it will give you 9 here, and this is equals to 13. So how can this equation be written? This equation can be written, this equation that we are having here can be written as 3 log x base 2, 3 log x base 2, this will translate to 1, the whole of this will be 1, divided by 2 will be 4, so we shall say this is 4 log y base 3 is equals to 13, and that become our equation number 2. Now, in order to solve these two simultaneous equations that we have formed here, we can, you see, we can use elimination. If we multiply this equation by 2, we are going to have a nice equation, which is going to be 2 log x base 2 minus 4 log y base 3 is equals to, here 2, and at this point we shall write 3 log x base 2 plus 4 log y base 3 is equals to 13. So if we add the two equations together, we are going to have log 5 log x base 2 plus 0 is equals to 15 at that point. So we have a nice equation which we can solve, and this is going to be 5 log x base 2 is equals to 15. Now, using logarithmic in notation to index notation, we are going to first divide by 5. Divide by 5, this will cancel out. We shall have log x base 2 is equals to 3, which will mean that if we take 2 power 3 is equals to x, x is equals to 2 power 3, and the final answer there is basically 8. X is equals to 8. Then we can be able to use any of the equation. We can use maybe equation number 1 here and say log x is 8. Log 8 base 2 minus 2 log y base 3 is equals to 1. All right. So which means that the whole of this is equivalent to what? This one is equivalent to 3, because we already know that this is log 8 base 2 is 3 minus 2 log y base 3 is equals to 1. This coming this side, we can have 1 coming this side, we can have 3. 3 minus 1 is equals to 2 log y base 3. So this becomes 2. So we shall have 2 is equals to log y base 3, because 3 minus 1 is 2, and we are having this 2 here. So 2 and 2 will cancel out. We shall have log y base 3 is equals to 1. So 3 raised to power 1, y is equals to 3 raised to power 1. In index notation, 3 raised to power 1 is y. So the answer for y is also 3. X is 8 and y is 3. If you are new to Proflan YouTube channel, consider subscribing so that in time I'm going to upload a tutorial like this one, you'll be notified. See you in the next video.